In this video, we're going to look at problem 7-2 on page 252. Here's what the problem says. A bond has a $1,000 par value, 10 years to maturity, and a 7% annual coupon, and sells for $985. So my pertinent information out of this problem is par value is 1,000. Maturity is in 10 years. There is a 7% annual coupon. And the bond is currently selling, so the present value is $985. Part A wants to know what is yield to maturity. Remember, when we lay out our keys here, yield to maturity is represented by I. N, maturity is in 10 years. Remember, N is number of interest payments until maturity, and these interest payments are annually, so N is 10. The present value, the bond is currently selling for $985, so make that negative. Our payment is $70, and the way that we calculate that, we take par value, multiply by 7%, the coupon rate, and that gets us 70. And the future value is my par value, $1,000. We should be able to look at this and get an idea of what the yield is going to be equal to. If we look at price, we see that the bond is selling at a discount to par, selling for less than $1,000. We know that when a bond is selling at a discount, we have a certain scenario that's in play, and that is that the coupon rate versus the market rate, we know the coupon rate is less than the market rate. So what we would expect to see is we have a coupon rate of 7%. We would expect to see this yield higher than 7%. And when we plug in our inputs into the calculator, we do see that yield to maturity, this is the answer to the question, yield to maturity is 7.22%, which is higher than my coupon rate. Now, part B asks this question. Assume the yield to maturity remains constant for the next 3 years. What will the price be 3 years from today? So in part B, we're going to set up NI, PV, PMT, FV. And what we're going to do is fast forward 3 years into the future. So back up here in A, we are 10 years until maturity. If 3 years go away, that means we're going to be 7 years to maturity. There's sometimes some confusion on that right there. So make sure you understand what's going on here. Up here, again, we're 10 years away from maturity. We're moving forward 3 years, so that means in part B will be 7 years from maturity. And we're going to hold this constant. So my yield is going to be 7.22. The question wants to know, what is the price going to be? The payment is not going to change at all, and the future value is not going to change at all. We need to think about some theory before we actually plug in anything. Notice that we're keeping all of these constant. That's constant. Payment is constant. Future value is constant. The only thing that's different is in part A, there are 10 payments until maturity, and in part B, there are 7. In the bond introduction video, I told you that as a bond approaches maturity, its price will approach par value, in this case, $1,000. So what we will anticipate is that since we're closer to maturity in part B versus part A, what we should see is a price higher than $985 from part A, but less than 1,000. So plug in these inputs and see what you get on the calculator. You should get 988.46. And that is the correct answer. So our theory was correct. It's greater than 985 but less than 1,000. Now I could go on and on with this, and we could change n to 4 or change n to 2. And what I would find is that as n goes down, the present value goes up, 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 closer to 1,000, but it will not go over 1,000 as long as this yield is higher than my coupon rate.